Hello, pre-calc. Sorry I'm missing class. My son's really sick, so I'm going to be taking care of him for a day or two, and while my wife goes back to work. All right, so we're doing this as a video lesson, and the section we're doing from our textbook is 7.3, which is the half angle formulas and the double angle formulas. Now, in the prior lesson, we went through the sum and difference formulas. So sine of s plus t, sine of s minus t. And when we have the sine of the sum of two angles, it's really difficult sometimes to calculate that. But by using the sum formula, the identity for sine of s plus t, we can get it into a form that we can work with. We're actually going to use these sum and difference formulas to derive the double and half angle formulas. All right, so let's get started. Okay, so you should have a copy of the printout that you see in front of you. And let's begin by deriving sine of 2x. So these are the double angle formulas. And let me briefly go back to my PowerPoint here. I forgot to say that what's our goal? Our goal is to derive sine of 2x. That's what we mean by the double angle formula. Sine of twice an angle. Cosine of 2x, tangent of 2x. And then the half angle formulas would be sine of x over 2 and sine and cosine of x over 2, etc. So we're going to do both of those today. All right, now let's actually get started. So first one, proving a double angle formula. So use the addition formula for sine to prove the double angle formula for sine. Let's remind ourselves what is the sine. Let me just put it up here. Let's just remind ourselves what is sine of s plus t. Well, sine of s plus t is sine of s cosine of t plus cosine of s sine of t. Okay, so that is the formula for adding two angles. We can actually use that to derive the double angle formula very easily. And the way we do it is the following. If we want sine of 2x, well, sine of 2x is just sine of x plus x. And so we can apply the double angle formula, we can apply the angle sum formula with x being the same angle for both of them. Okay, so I'll just plug into the one up on top, this one. I'll plug into this one where s is x and t is x as well. So we have sine of x cosine of x plus cosine of x sine of x. And you can see that these are like terms. I could rearrange it, but it's just 2 sine x cos x. And all we did here was just swap the order of these with the commutative property of multiplication. So we have a formula. Our formula is this. Sine of 2x equals 2 sine x cos x. Now again, just like in the prior, if I have sine of 2x, that could be difficult to evaluate. But I often am able to do sine of x, no problem, and cosine of x, no problem. So we've turned something that might be difficult to evaluate into something that's easier that we know how to work with. Okay, so there's the double angle formula for sine. And these are all on your identities note sheet. Okay, let's see. So what's next? All right. Proving a double angle formula for tangent. Now for tangent, we need the tangent formula, which you can refer to on your note sheet. And it would be tangent of, instead of 2x, it's going to be x plus x. Now we just apply the tangent double angle formula. we apply the tangent sum formula, and that is tangent of x plus tangent of x over 1 minus tan x tan x. Okay, and we get 2 tan x over 1 minus tan squared x. And that's it. That's the formula. So we end up with, and I'll just put a little emphasis on this, we have tangent 2x equals 2 tan x over 1 minus tan squared x. This is an identity. So whenever we have tan 2x, we can replace it with what's on the right. And tan 2x might be difficult, but tan x is often easy. Okay, so there are two examples of double angle formulas, one being sine and one being tangent. Let's do cosine, and then we're done. Now, same process. You could probably anticipate this, but cosine is a little interesting because there's actually 3 different versions of the cosine double angle. But we start out the same way. But now we're going to use the cosine sum formula, which is cos x minus sine x sine x. Okay. Should make that a little bit smaller so it doesn't encroach on the next one. Let's do this. Okay. And we're done. Cos squared x minus sine squared x. So we know that cosine squared plus sine squared equals 1, but it turns out that cosine squared x minus sine squared x equals cosine 2x. Another identity we've proven. And now you can use it. You can use it if and when needed. We'll see some applications in a minute, and then you'll get to practice some on the homework. Okay, now there is another way we can write cosine 2x, and we do it with a substitution. So we know that cosine 2x is equal to, well, we just derived it, so we know it's equal to cosine squared x minus sine squared x. But what we can do is we can use the Pythagorean identity, and that is cos squared x plus sine squared x equals 1. I'm just writing this as a reminder note down below. So cosine squared here is equal to 1 minus sine squared. So cosine squared x equals 1 minus sine squared x. And so we can substitute this expression on the right. We can substitute that in place of cosine squared. And we get 1 minus sine squared x. That's a replacement for cosine squared. Minus sine squared x. Okay, and then just combine like terms. And we are done. So now we have another one. Cosine 2x is the same thing. It's identical to 1 minus 2 sine squared x. So now we've got another identity, a replacement. All right. Okay, that one's going to be super important in a minute. We're going to use that for the half angle identities, which you will see. And we can do the exact same substitution, but instead of substituting for cosine squared in here, we can solve for sine squared and substitute it in here. So let's do that. Cosine 2x is, well, the first identity is this minus this. Okay. And now I'm going to leave cosine squared alone this time, but I'm going to substitute in 1 minus cosine squared in place of sine squared. Now, if I distribute the minus, this becomes a minus 1 plus cos squared x. Combining like terms, I get 2 cos squared x minus 1. So cosine 2x equals 2 cosine squared x minus 1. And we have it. Okay. So good. Yeah, so I was just making sure we did everything, and we've just proven the double angle formulas for sine, tangent, cosine, and then there's 3 different versions of cosine. Now, on your formula sheet, you will see all 3 of them. Very easy to derive, and it's something you can do yourself. And so if you ever forget what sine 2x is, you can rederive it if you know the sum formula. But here are the identities, and then you'll notice that cosine 2x is written 3 different ways, and all of them are useful at different times. All 3 of those. Okay, how do we use it? So using the double angle formula. Now, if let's see, example 1, yes. So if we have this problem, let's look closely. It says if cosine x equals negative 2/3 and x is in quadrant 2, find cosine 2x and sine 2x. Okay, first thing we need to do is draw the angle. So the angle is x, and we are given that cosine x equals negative 2/3. Well, cosine is the x-coordinate over the radius. So that means we must have a right triangle that's in the second quadrant. And this angle x, the angles always go from the positive x-axis to the terminal side. And the sides of this triangle are going to be negative 2, and the hypotenuse is positive 3. Because we're given that cosine of this angle here. And I just realized I should label this x, and cosine of x is the x coordinate divided by the radius. Okay, now to find the other side, we need to do Pythagorean theorem. And we get 3 squared minus negative 2 squared, which is 9 minus 4 equals 5. So, and that is this side squared. So that would be like y squared, the y coordinate squared. And so y equals the square root of 5. And it's positive because it's going up. All right, so we've got all the sides of our triangle. We, of course, know that's a right triangle. And now that we've got that, we want to find cosine 2x. Now, cosine 2x, well, I don't know what angle cosine 2x is. It might be over in the third quadrant, it appears. But, oops, I said the right thing, but wrote the wrong thing, 2x. Okay, cosine 2x. I don't know how to work with that, but I do know how to work with x because I have the picture in front of me. So what's an identity for cosine 2x? Well, how about cosine squared x minus sine squared x? Okay, now I can write it like this. Cosine squared, junk squared. What is cosine of x? Cosine of x is what was given. It's negative 2/3. So this is negative 2/3. What's the sine of x? It's root 5 over 3. Root 5 over 3. And just to really emphasize that, we're squaring cosine of this angle x. Here's the angle x. Cosine of it is -2/3, so I just put it in here and square it. Sine of x is opposite, or the y-coordinate over the radius, √5/3, so I put it in here and square it. That's it. And I just bring this together. Let's see, what does that end up being? 4/9 minus 5/9, so -1/9. Done. That's it. So that's an application of the double angle formula. And while we're at it, we could do the same thing with sine 2x. Sine 2x is 2 sine x cos x. And sine x is, we just said it, it's √5/3. And cos x is what was given, -2/3. And multiply that out, you know, -4√5/9. Okay, there we go, that's it. What's another way we can apply excuse me, what's another way we can apply the double angle formula? Well, we could actually use we can use the double angle formula to derive a triple angle formula. And we actually could repeat this and find a quadruple angle formula and cosine of 5x, etc., and cosine of nx in general. Let's find cosine of 3x, and we're going to write it in terms of cosine. So I want a new identity, and I want it to be cosine of 3x, and I want it to be equal to something that only involves cosine x. So how can we start with this? Well, we kind of do the same trick we were doing earlier, which is to break up the 3x into two things that are helpful to us, and then we'll use the sum formula because we know the cosine of the sum of two angles. So what I'm going to do is write it as cosine 2x plus x. We'll use the cosine sum formula, which is cosine of the first one times cosine of the second one minus sine of the first one times sine of the second one. But now you see we can apply the double angle formulas. Well, I want my answer, remember, I want my answer to be in terms of cosine. So what's a good choice of cosine 2x? Remember, there were three. We had three. We've got these three different choices. Do you notice this one in cosine 2x, if I choose this one, it uses cosines and sines. But the question said we wanted to write it in terms of cosine only. So this bottom one is the best choice. 2 cosine squared x minus 1. Because the question said, write cosine 3x in terms of cosine only. So we don't want any sines. We don't want any tangents. So cosine 2x is 2 cosine squared x. That was a funky squared. Let me fix that. That's an s squared minus 1. So that's the identity for cosine 2x. And I'm just going to leave this cosine. Minus, now sine 2x, that would be 2 sine x cos x times another sine x. Okay. Now we're going to get a sine squared, and we can substitute that out with the Pythagorean identity. If I distribute the cosine, I get 2 cosine cubed x minus cosine x minus 2 cosine x sine squared x. Don't know why I'm like mixing using parentheses and not. That should be okay. Okay, now we'll get rid of the sine squared x because we want it in terms of cosine only. 2 cos 3x, 2 cos cubed x, minus cosine x minus 2 cos x 1 minus cosine squared x. That's the Pythagorean identity. And now we combine it all together. And I'm going to get 2 cos squared x minus 2 cos, 2 cos cubed x. And then notice that this is minus 2 cos x times negative cos squared x. That's going to give me another cosine cubed. Positive 2 cosine cubed when I do the distributive property. So that will leave me with 4 cosine cubed x. And then what? Minus cos x minus 2 cos x times 1. So that'll be minus 3 cosine x. So we have just derived a triple angle formula using the double angle formula. We've derived this formula. Cosine of 3x is 4 cosine cubed x minus 3 cosine x. Here's a formula. Okay. Now, this is one that, so we're going to prove this identity. This would be kind of a tricky one. It's one you could try, so you could pause the video and you could give it a shot on your own if you wish. But let's work through it. Now, we always want to start with the more complex side. Both sides kind of look similar, but we just did derive, let's see, we could figure out how to handle sine 3x using the same trick. So maybe we'll start with the left-hand side, and then the solution does suggest starting with the left-hand side. So let's do that. I'll pick blue, and I'll start with what? Sine 3x over sine x cos x equals, same trick, sine of 2x plus x over sine of x cos x. We'll use the sine sum formula in the top. Sine of, let's see. Actually, just so that I'm consistent with my notes of how I wrote it up when I was doing this, I wrote it this way, and just so I don't mix things up, I'll write it the same way. So I've split up 3x into x plus 2x. And so I've got, now I need the sine summation formula. That's sine of the first one times cosine of the second one plus cosine of the first angle, sine of the second angle, and that's 2x. And I'll just keep copying this down on the bottom. And let's see, so I can rewrite cosine 2x using, so and here's where it's not totally obvious what you should do, but with a little trial and error, you can figure this out. We need to get rid of cosine 2x, and we need to make it like this right-hand side. What does work is to use cosine 2x is 2 cos squared x minus 1 plus, and then I've got cosine, and we use the sine double angle formula, and there's only one. 2 sine x cos x, and then all over sine x cos x. And now, and this one is a little bit tricky, so but we can divide this bottom into here, and the sine x will cancel, and we can divide this bottom into here, and the cosine x will cancel. And if you think ahead of where you're trying to go, this is 4 cos x, so I want the sine gone. And this is secant, So it would be nice. So I noticed that this cosine's going to cancel, and I noticed this sine would cancel with that sine. And we will just have to see if we can make it work. Okay, so sine of x, 2 cosine squared x minus 1 over the denominator plus cosine x 2 sine x cos x all over that denominator. I guess I could have written that a little nicer. I could just put the 2 in the front. And I'll get 2 cos x sine x cos x. On the bottom, I have sine x cos x. And a bunch of stuff cancels. So these cancel, these cancel, these cancel. And yeah, so what else can we do with this? I can also divide that cosine x into the cosine squared and the cosine x and divide that into the 1. What's really nice about that is I'm looking for a secant. Remember, I'm trying to get to a secant, and that's 1 over cosine. And I'll get that out of the left-hand term. So I can do 2 cos squared x over cos x minus 1 over cos x plus 2 cos x. Okay. And we've got 2 cos x. 1 factor of cosine cancels with 1 factor in the top. Minus secant x plus 2 cos x. And we've done it. 4 cosine x minus secant x. Okay, again, not something that's necessarily obvious, but we have proven this identity. And we used a bunch of different identities that we have seen before. You might not do this perfect. I had my notes worked out in advance, and but you might not do this perfectly the first time. You might have to try something and see where it goes. Try a different idea if you get stuck. But we have proven that this, the left-hand side, is equal to this, the right-hand side. So that identity is proven. Okay, so that's half the lesson. The other half is deriving the half-angle formulas. Now, the half-angle formulas all come from the double-angle formulas. And the half-angle formulas are, well, the double-angle formulas are all sine of 2 times an angle, and the half-angle formulas are sine of half of an angle. And oh my goodness, there's these square roots in tangent of u over 2. Well, and you might think, like, how do you derive one from the other? Well, it turns out you use the double angle formulas to derive the half angle formulas, and you do it via a tricky little substitution. Here's our tricky little substitution. So 1, you substitute in for this. Notice their u down below and their x up here. That's because we're going to do a substitution. And what we're going to do is we're going to let 2x be u. So we're going to replace it just by relabeling it as u. And that means that x is equal to u over 2. That's step 1. And then step 2, so what does that mean? That means the 2x is going to be like a u, and x is going to get replaced with u over 2 and u over 2, and you can see where the half angle is going to come from. Okay, and the one we'll really use is we'll use these two especially and, for cosine. Oh, right. Great. And then step 2 will be then to solve for whatever solve. Once we do the substitution, we will solve for the trig function you want. Whatever that is. So if we're trying to find cosine of u over 2, we'll get cosine of u over 2 by itself. Okay? And then 3, we need to just to take note. I'm just going to say, take note of the plus and minus signs. And we'll discuss like how to handle the plus and minus signs that come out of this. Okay, so here are the half angle formulas. Let's prove them. Again, pretty straightforward if you know prior identities, and you can rederive these very easily with by knowing your double angle formulas. Okay, so to prove sine of u over 2, it turns out what's helpful is this identity. And this, the cosine, remember how we had the cosine double angle and there were 3 versions? Well, this was one of the versions. And what I can do is I can rewrite this as cosine of, instead of 2x, I'm going to write u equals 1 minus 2 sine squared of, and since 2x is u, x is u over 2. So I've just done a substitution, and now I just solve for sine of u over 2 using algebra, and I'm done. So I get cosine u minus 1 equals negative 2 sine 2 u over 2. Divide both sides by negative 2. And I get negative cosine of u plus 1 over 2 equals sine squared u over 2. Now I want sine of u over 2 by itself, so I take the square root of both sides, and I'll flip it around here. So the sine of u over 2 is the plus or minus square root of this side. And so just to emphasize, we're taking the square root of both sides and doing plus or minus. Plus or minus the square root of 1 minus cosine u over 2. Now you, and that's it. That's the identity that's in the box. Now you will see that sometimes these are written with, well, with any variable. I could put, instead of u, I could put theta, or I could put x or t or whatever. Now you may wonder, why plus or minus? We use the plus whenever the angle u over 2 is in a quadrant where sine is positive. So remember, sine is positive in the first quadrant and it's positive in the second quadrant because the y-coordinate is vertical. It's up above the x-axis, and sine is negative in the third and fourth quadrant. So if u over 2 happens to, if u is here, then actually let me write that another way. If u is this angle, then u over 2 is half that. And so that means u over 2 is in the first quadrant. So we would use the positive square root, not the negative. And if our u over 2 was in the third quadrant, we would use the negative. All right. You can derive the other, I'll switch to purple here. You can derive the other two half angle formulas in a very similar way. You just use, for the cosine half angle, you just use the other cosine double angle formula. So cosine 2x is 2 cosine 2x minus 1. And we do the substitution. This will be u. 2 cosine squared u over 2 minus 1. Now we just solve for cosine of u over 2. And I will get cosine of u plus 1 divided by 2 plus or minus square root equals cosine of u over 2. And there it is. Okay. Now, tangent of u over 2 is a little bit of work. I'm not going to do the whole thing, but I will tell you that it starts out this way. Tangent of u over 2 is sine of u over 2 over cosine of u over 2. And we know those formulas because they're highlighted on the left side of the same page. And this gets a little bit tricky, but you would end up with these square roots like this of the two formula, and you need to actually multiply by the conjugate in the numerator. And I will just say that a full derivation, I believe, is in the book, and you will end up with what we need to know is sine of u over 1 plus cosine u. Okay, I'm going to, just to shorten this video and not make it too long, I'm going to do this. So we've got our formula for the tangent of u over 2. Okay. All right. And that is that. So tangent of u over 2 is written in terms of sine and cosine. And how do we use the half angle formulas? Well, here's a pretty basic example. Suppose we want to find the sine of 22.5. Well, we know that 22.5 is half of 45, and sine of 45 is easy. So let's try that. Sine of 22.5, well, that can be written as sine of 45 degrees over 2, or divided by 2. But we just had the sine half angle formula, and the sine half angle formula is the following. Let me do this. Okay. The sine half angle formula is, let's see if we remember that, it's sine of u over 2 equals plus or minus the square root of 1 minus cosine u all over 2. And we're going to use that because the left-hand side can be annoying, but the right-hand side, although there's a square root, it is something I can evaluate by hand because cosine of u is simple. All right, so let's do it. So we have sine of 45 over u. Sorry, 45 over 2. So that is the same as plus or minus. Now, do we want plus or minus? 22.5 degrees is in the first quadrant. Sine is positive in the first quadrant. So we want the positive square root. 1 minus cosine of 45 over 2. Now remember, this is sine of 45 over 2. So that means wherever there's a u, I'm putting 45. And notice this is 1 minus cosine u, so I put 1 minus cosine 45 over 2. Cosine 45 is root 2 over 2. Root 2 over 2 over 2. Okay. And I can multiply top and bottom of this fraction underneath the radical, 2 over 2. That'll clear this denominator. Square root of 2 minus root 2 over 4. And I can take the square root of 4 and bring that out. So in the front, I would end up with 1/2 square root of 2 minus root 2. So there's actually a square root underneath a square root. So the sine of 22.5 is 1/2 square root of 2 minus square root of 2. So the half angle formulas and double angle formulas allow us to calculate a bunch of things by hand that we couldn't do otherwise. Okay, one more example, and actually just 2 quick examples to finish up, and then you can do a lot of practice. Okay, so if I have tangent of u over 2, we need to remember. Sorry. We want to find tangent of u over 2, and we're given that sine of u is 2/5 and u is in quadrant 2. So this is similar to one we did earlier. If sine is 2/5, that means the y coordinate is 2 and the hypotenuse is 5. So it's got to be a little bit shorter. This is 2 and this is 5, and our angle for u is this. U is that. And okay, so yeah, let's see. So we need to use the quadratic formula to figure out this other side. Well, that would be 5 squared is 25, 2 squared is 4, 25 minus 4 is 21. So this side would be square root of 21, and it's negative because it's going to the left. Okay. So to use the half angle formula for tangent, we actually need to find cosine of u, and since cosine is negative in quadrant 2, we have the following. So we have let's see, so we have cosine of u is equal to negative square root of 1 minus sine squared u. Now, what did I do there? I'm using okay, let me okay, hold on that for a second. I probably should have said this, because what I'm trying to do is I'm trying to use tangent of u over 2, and remember the formula that we derived earlier. If we go back and look at it, tangent of u over 2 is one version is sine u over 1 plus cosine u, and another equivalent version is the following, and we didn't prove this, but another equivalent version is 1 minus cosine u over sine u. And we're going to use this one on this problem, 1 minus cos u over sine u. Let's come back down. Okay. So just hold on to this fact for a second, and I'll come back to that. Tan of u over 2 is 1 minus cos u over sine u. And that's one of the half angle identities on your identity sheet. And now the reason I needed to use this Pythagorean identity is because I need to know cosine of u. Right. So, I was just thinking that a simpler way, I don't even actually need this identity. I realized I used this identity when I did the notes originally, but I actually just realized there's actually just a simpler way to do this. That actually just overcomplicates it, because I can actually just use the picture. Because what does what is cosine of u from the picture? Cosine of u is the x coordinate, or the x side of the triangle, divided by the hypotenuse. And what is the sine of u? We can get it right from the triangle. It's 2/5. So we can actually just plug this straight in. One minus, and cosine u is negative root 21/5 all over sine of u, which is 2/5. And this is actually much simpler than the way I was going to do it. I just realized right now that I can do this in a simpler way. And so I get, 1 plus root 21/5 all over 2/5. I can multiply top and bottom by 5, or I can flip and multiply the fraction and distribute. Either way, the 5s are going to cancel. You're going to end up with, 5s will cancel on this. You'll end up with 5 plus root 21. Root 21 over 2. Okay. Now, by the way, if I would have used, remember there were two versions for tangent of u. So if you look at your formula sheet, you'll also find that tangent of u over 2 is equal to sine of u over 1 plus cosine of u. If I had used the other one, it will still work, because I will just get 2/5 in the numerator. Down in the denominator, I'd get 1 minus, negative, 1 minus, let's see. Sorry. Because this is plus, that would be plus. And then I'd be putting in cosine of u, which is negative root 21/5. And if I multiply top and bottom of this fraction by 5, the 5 cancels that 5, so the new numerator is 2. 5 distributes to that one, 5 minus, this 5 cancels that, root 21. And are these the same? They are, because we can rationalize the denominator. And you may remember that to do this, you multiply top and bottom by the conjugate of the bottom. When you do that, the top is 10 plus 2 root 21 over 5 times 5. This is a special factor pattern, so I'm going to get 5 times 5 is 25. 5 times positive root 21 is 5 root 21. Minus 5 root 21 minus 21, because the square root of 21 times the square root of 21 is 21. And I get 10 plus 2 root 21 over 25 minus 21 is 4. Cancel a factor of 2 in everything, and I get 5 plus root 21 over 2. And they are the same. Notice that this is the same thing as this, using either method. Okay. I think example number 8 would be a really good example for you to do. So I think I'm actually not going to do that one, and I'm going to leave it here. So you should try number 8, and then you will have a set of problems to do from the Mastery Check packet. And then whatever you don't finish, we will we'll continue practicing this, is what I should say. We'll continue practicing this on Friday. All right, I'll see you in class next time. Bye.